It's starting. Okay.
Well, I definitely have this. Maybe this. And this to the side of that. There's only one thing left to do. What are you up to today? Wreck my will? Dude, why? Have you seen what I'm sick with? Look at the whole list. Well, that escalated quickly. What illnesses? Have you been reading my medical encyclopedia again? Yeah. Oh, by the way, do you know what would be awesome? Not drawing pointless conclusions based on zero evidence? Nah. If a machine could diagnose the sickness, will that stop you from wrecking at will? It could, if it reads my symptoms correctly. Oh, come on. Even my 8-year-old son can tell that you don't have Alice in Wonderland syndrome. But I could have it. All right. Let me think about it. I have another idea for you. Will you actually appreciate this one? Yeah. Okay. What is it? I want you to make a machine that can beat a grandmaster. That's oddly specific. Why a grandmaster? Those guys are notoriously strong. So beat grandmaster. Dude, have you heard of Isaac Asimov's laws of is he a grandmaster? Not that I heard of. Forget about him. A grandmaster is a goal. And do you know what else I was thinking about? Kids. Oh no. Oh yes, we can use them. No. Train on them. Start with something weak and then work our way up to something strong. Dude, what kind of childhood have you had? A normal one. Why? No reason. And once we've trained, we challenge the master. He will know what hit him. Here we go again. Checkmate, mate. A what? Check and mate, chess stuff. Chess stuff? What do you think I was talking about? Oh, chess stuff. Oh my God, of course. So you think you can build this? Because that, my friend, would make a real breakthrough for your AI research. You will make a mark. Hey, why so sad? I just broke up with my girlfriend. Dude, so sorry. You know what would be awesome? I am not making you an artificial girlfriend.
Hello. Hello,
Hello.
everyone. Welcome to the new series of Exactpro YouTube channel, AI Testing Talks 2024. I am your host, Anna Maria. I work at Exactpro, and I'm an outreach director of our educational project AI Testing course. Assisting me today is Exactpro co-CEO and co-founder, thought leader, and AI testing practitioner, Yosif Itkin. Hi, Yosif.
Hello, everyone. Hello, Paul. Hello, Maria.
Hi. Hi. Let me tell you about the project, and I'll introduce you, Paul. So at this series of webinars, we dive into artificial intelligence technology and combine it with human potential. So we are trying to identify the way of harnessing AI capabilities in software testing, exploring AI technology and software testing in various aspects, including generative AI, AI-powered test tools, the impact of AI biases and its role in software testing. And today's guest has a vast experience in engineering and software testing with focus on AI and ML in software development. Paul Gerrard, software consultant, author, teacher, coach, and founder of the Test Engineering Society. Hi, Paul. It's a pleasure to see you here at our session.
Thank you for having me. It's very good.
So before we jump into the presentation, you can start sharing your screen, Paul. So I wanted to mention that today's session is going to be divided into two parts. So one of the part will be the presentation itself, and another one is a QA session. So together with Joseph, we've prepared a set of questions for you, Paul, which we are going to raise right after the presentation. And we have also collected and received a few different questions from our audience via Google Forms and emails and LinkedIn. And everyone who are now watching us at YouTube channel, please feel free to send your questions via YouTube chat, and we are going to address them right after the presentation during our Q&A. So without further ado, please, Paul, over to you.
Thank you. Thank you for having me, and thank you for letting me talk about a little hobby of mine. For the last couple of years or so, I've been tinkering with AI, and when ChatGPT 4 came out, it all got very exciting, and I spent quite a lot of time playing with it. I paid for the service, so you get a bit more out of it, certainly for ChatGPT 4. And it seemed very exciting, and it's a good thing. But what I wanted to do is actually, I wanted, like everybody else, to have my own version of ChatGPT here on my desktop or in my, I want to say living room. I don't mean living room, but in my own house, if you like, because I work from home mostly. And I want to experiment with it. I want to do a lot more than just ask 20 questions a day. So anyway, so what I'm going to talk about ultimately is about, I'd call it a hobby, but the question I want to explore, but maybe not answer, maybe we discuss it a bit later, but will RAG transform testing? ChatGPT on its own, GPT on its own, I don't think is enough. We have to be allowed to put our own data into these tools in order to ask questions of that data and to infer what's going on in it, to understand what we can get out of it. So if you like, I wouldn't call myself an expert. I'm an experimenter at the moment. That's probably how I would put it. I would say I'm a hobbyist. I'm looking to do some business through this, but right now I'm not sure what that business will look like. I have a certain idea, but we'll see. So what am I going to talk about? I'm going to ask the question, why do you need your own GPT? Why would you want to do it for yourself? I'm a kind of a techie at heart. I was a developer. I still am a developer, but not so much as I used to be. I want to talk about how I built my own hardware to do this. Now, having gone through that idea, how do GPTs work? You have to understand at least a little bit about how GPTs work to understand what it potentially can do for you. And the hype that surrounds AI, I don't know if it's peaked yet, but all the attention is on large language models. And large language models have great potential for some things, but not everything. They're not going to solve all the world's problems. GPT is not going to, or language models and GPT are not going to transform testing in the way that some people might be talking about. And there are other people who are saying, no, it's all nonsense. It will never happen. It's a anathema to them almost. I want to suggest that what we need from AI are thinking tools, and I'll explain that when I get to it, because thinking is the essence of what we do. Yes, we might use tools. Yes, we manipulate data. Yes, we keep test records. But ultimately, we are thinkers. All our value to our projects is in what's going on in our heads. Okay, so I want to talk about my vision for AI-supported testing. Now, it's some way off, but then it doesn't. I don't think it has to be some way off. I think we have the technology to do an awful lot of what I think would be incredibly valuable to us. So hopefully get to that at the end and talk a little about what tools, what I think tools should be doing for us as testers. So why would you do it yourself? Well, the general idea with the products that are out there is you pay for them. And ChatGPT has had an awful lot of attention. The OpenAI version of a large language model with a usable, friendly, interactive interface. But you pay for what you get, and there are limitations on what you can do with it. Now, this thing is moving on, and right now, ChatGPT 4.0, or is it 4.0? I think it's 4.0. Is being discussed and presented to the world, and it's going to evolve a lot more in the next year or 2 years or 5 years. So ChatGPT 5, 6, 7, who knows? That's all on the way. But large language models on their own aren't everything, and I want to explain why. And the other angle with GPT is it's trained on data that's firstly out of date. It's of an unknown origin. We don't know where it came from. They don't, it's not, that information is not shared with us in general. We don't know its reliability, its provenance, and yet we're asked to believe the answers that it gives us when we ask it questions. Now, we obviously have seen some enhancements whereby GPT can do lookups, and do Google searches and find web pages as references for some of the content. And it's doing behind the scene some ingestion of data from websites to service its responses. But at the end of the day, that's not your data either. What we'd really like to do is be able to put our data in and use the capabilities of LLMs to ask questions of that information, of those documents, those PDFs, web pages, whatever, images, audio, all that kind of stuff. We want to ask questions of that stuff to get answers. Now, that's available now in some respects, with varying degrees of openness and commercial expense. But perhaps the biggest deal with doing your own private GPT as opposed to using a public one is privacy. So I don't want to talk about this any longer. I just want to suggest that Retrieval-Augmented Generation right now is the step forward with large language models, to be able to put in our own data, to capture our own data, and obtain answers to questions we have of it. There's a definition of RAG. I don't want to dwell on it, except I want to suggest we can use the LLMs as a language engine, and we want to couple that with our own data to get answers of the documents, the content that we are most interested in. So the general idea is to load some documents into a tool, ask questions of that content, and potentially ignore the LLM training data. We're just using the LLM to, if you like, manage the conversation and find the answers from our content, not this mysterious content that LLMs have been trained on. Now, the next question is, well, don't you need million-dollar hardware to run these kind of tools? And the answer is not really. Over the course of the past 2 years, for as long as I've been sort of looking at this stuff, it's become clear that the hardware required to do this, you can run an LLM on your desktop or laptop. Okay, that's perfectly possible. Even mobiles, I've kind of seen a little evidence of that. But the speeds are slow. Okay, if you have a large model, the speeds are slow. At the end of the day, what you need is a powerful GPU to offload the matrix calculations. Most of the horsepower required is to perform very large scale matrix manipulation. Now that sounds terribly technical, but if you've got a maths background, it's not so scary. It's large tables of data being processed endlessly at an endless scale. So some of the quantities of data can be huge, and the number of times that it is processed again and again in an iterative way to get closer to an answer means that you need hundreds of teraflops of horsepower. Now, how do we do that? Do we buy massive supercomputers, or can we buy a GPU that actually has 10,000 processors? Functionally, it has 10,000 cores in there. And that's what the name of the game is nowadays, that GPUs are becoming the mechanism to deliver AI and certainly large language models. So, okay, what was my plan? Well, a long time ago, I built my kids' PCs from scratch and with varying success, but it generally worked. And I'm a bit of a kind of a hobbyist, and I like doing a little bit of do-it-yourself. But building computers was something I thought I'd give a try. And so I thought, well, why not I just buy the parts from China? Now, there's an architecture called X99, which historically was used for servers, and 10 years ago, the biggest servers that were available commercially. Now, that architecture has moved on. It's kind of obsolete. Intel don't build computers using X99. But two things have happened. One is there is a glut of chips from those generations of servers. And the Chinese have made great strides in building reliable motherboards. And so actually we can get industrial strength server capability out of relatively cheap hardware. Costs are low, and second user processors plucked out of older corporate hardware are plentiful. There's a lot of them on the market. They're cheap. They can cost $15, $20, whereas they used to cost $500 potentially at the top end. NVMe's are storage, so literally computer memory as storage is now very popular. Laptops have had these for years. They're becoming cheap at scale as well. So very large disks can be bought for not a lot of money. NVMe's just screw straight into the motherboard. So they kind of remove the need for cables and disk drives and a lot of that stuff. I thought self-build might be a bit of fun. That's questionable. But ultimately, what you end up with is it's a gamer's rig. It's a gaming machine because it's a platform for a very powerful GPU. The machine I've built and the machines that people are building for gaming are appropriate. Those are the appropriate architectures for running large language models and experimenting with AI. So here's my shopping list. I don't want to go through this in any detail really, but it's real hardware. It comes from China. You wait for a couple of weeks. The total cost for me when I added it all up was $1,600 or so. And that was the case, the motherboard, 256 gigabytes of memory, and a second user GPU, which was an NVIDIA RTX 3090. And that's kind of the star of the show. And the whole purpose of the hardware is to host the GPU. Now, the GPU is incredibly heavy, I have to say. It's about so big, it's quite a lump. It's about, 75 mil deep and about 250 millimeters long. It weighs kilograms. It's really heavy. It's like a big piece of metal. Now, what does it do? I mean, I don't care. But the critical thing is this element here. 10,496 CUDA cores. Now, a CUDA core is what? A CUDA core is the architecture that NVIDIA have built to use their hardware to deliver extremely powerful graphics capabilities. But graphics very much depends on mathematical calculations using huge arrays of data at very high speed. So this card, it's not really a card, it's a big lump of metal, has 10,496 processors effectively processors, which can process mathematical operations at great speed with massive amounts of parallelism, okay? Now, the one I've bought is a 3090. It scores 8.6 on compute capability. Well, what does that mean? On Wikipedia, if you look it up, CUDA capability, the card I've got scores 8.6, and effectively that puts it quite high up on the hierarchy of power. It basically does everything, this green line here, this vertical line here, it does everything to the left of it, and doesn't yet, or couldn't, do the operations towards the bottom of this table. So it's kind of up there. It's kind of an obsolete piece of kit, but it's 2 or 3 years old, but it's perfectly capable of running what we need to do. So it took me a couple of hours to build it. I mean, you could do it faster, but I'm out of practice. Everything worked well, apart from the NVMEs, which I bought for $35 or so each. 4 terabytes. 4 terabytes of data for $35. That's crazy. And it was too good to be true, because I actually bought 6, because I built 2 machines, one for collecting data and one for doing the analysis of that data. And I think 3 out of the 6 just failed. They just didn't work. So I kind of stepped back from using them. I just bought some regular SSDs from Amazon for a couple $100, and that's what I'm actually using now. I do have some NVMEs in the hard drive I've got, and I'm just seeing how they behave, because it's not good enough that 3 of them did not work out of the box. So there we are. I installed everything under Ubuntu workstation. Configuring the GPU was troublesome, because I thought I'll have the massive GPU for the AI stuff and a GPU for the user, for the GUI on the server itself. That wasn't a good idea. Just let the one GPU deal with everything, and you've obviously got to get exactly the right software versions for the drivers and so on. And the CUDA software itself has to be just eased into place. Let me put it that way. It's all software, but it's quite delicate operation to actually get it working. Anyway, the software I want to use to run the GPT is called Private GPT. It's an open source product. It seems quite well received, had a lot of downloads. There's quite a few YouTube videos of people experimenting with it, of building their software platforms, but there's not much evidence of it being used for anything useful, because people are keeping that to themselves. I mean, I guess maybe they want to make money out of it, or I know they want to make money out of it. There are quite a few alternatives to this. There's a local GPT and several others that are kind of packages of software using selected language models, vector databases, and so on, the components themselves. So they're kind of an integration tool that are running a lot of the components that deliver an AI solution. I actually use Mistral 7B, which is 7 billion element model. It scores very well compared with the OpenAI products, ChatGPT in particular. The links relate to how do you get the thing installed, and there is evidence of people doing it, and there's videos that can help you get something out of this kind of game. Now, this is the UI of Private GPT. It doesn't look terribly exciting, but you can see there are 3 options, 3 buttons at the top left. Query files, which is ask questions of the data you upload, of the files you upload, or I should say ingest. Search files, there's a search facility there. I haven't used that very much, I have to say. And then there's the third one is LLM chat, which is actually ignore the data you've uploaded and just talk to the LLM. And that would be kind of like talking to ChatGPT as it currently stands. You can upload files. And that's the model I'm using, Mistral 7B, blah, blah, blah. What else? And then you type a message at the bottom. Now, there are clear opportunities to parameterize this and change it, because it's a Python product. It's all open source. You see all the configuration details. I haven't investigated all of them by a long way, but there's a few changes I've made just to see if that has an effect. The GUI is fun to use. Okay, it's just like ChatGPT, as you probably have seen before. But ultimately, I want to use the API. I want to write Python to upload documents, to analyze those documents, store the responses in a database, and use that as the basis of doing some analysis. Now, I can talk about that, but probably not today. That's kind of my project, really, why I'm doing this, okay? The other angle of this is I'm going to filter pages that I download and ingest into the model. For some time, I've been working on what I've called a testing glossary project, where I've literally just taken glossaries from various sources. I'm using those as a broader definition of testing terminologies. It's just about testing. So I'll come back to that a little bit later. Here are the two boxes. I've got two boxes because one's running GPT and the other one runs virtual machines, but essentially it's running one virtual machine, which is a downloader, which is scanning websites. It can download, I haven't done the arithmetic, but it's about 200 pages a minute. So it's hundreds of thousands of pages a day, potentially. I don't think I'm going to be in those realms. But I have to say, I've already downloaded about 300,000 pages with it, and it seems capable of doing that. Anyway, that's the hardware. It's not very interesting, is it? It's two black boxes. Now, just so you might trust me that I'm not just talking about something on paper, but I've actually done this. I think, here we go. This is a little video, which won't last very long. I upload files. I downloaded a PDF from the Exactpro site. I think you'll see it uploading now. Okay, so it's processing. You can see over here. And I think it takes about 14 seconds. I've kind of edited the video just to speed it up. But this is how long it takes to ingest, I think about 45 pages, something like that. So there's the file. Now I can ask questions of it. And I ask, where do Exactpro have offices? And I get an answer, which looks reasonable. Next, I think, what do I ask? What testing services do Exactpro provide? And I get a summary, but there's no detail there, no structure to that answer. So I ask for a bit more detail, provide more detailed service descriptions, and I get something a bit better. Now, I'm not checking this. I haven't checked this. I'm not worried about this. I'm just trying to show that I've got something that actually works. Okay. So trust me, I've got something that actually works. I think I need to go. Right, so the next question is, how do GPTs work? So I've got something that looks a bit like ChatGPT, but you need to understand how GPTs work to trust them. And trust is probably the biggest question that people have, is how or why or what evidence can I see that I should trust these things, that they do what I want to do? They do what I want to do. They tell me what I want to know. Well, GPT is generative pre-trained transformers or transformer. Generative, it generates raw text. Pre-trained, it's based on a massive amount of data, training data, and it's not finished. It's never finished. You can always add more data to these models, pretty much. All the work is done by the transformer. All the clever stuff, the really clever stuff is in the transformer. And essentially what it does is it takes some text and it will answer the question that text poses. So it might be an unfinished sentence and it will add what it thinks is the best completion of that sentence. And responses internally to the products are called completions. That's what they do. They complete an idea, a question, an unfinished sentence. They complete what you provide it with, okay? There are 4 processes built into the transformer: embedding, attention, MLPs, unembedding. I'll talk about that in a moment. But the transformation aspect is things are broken down into small units, small clusters of content. So those clusters of content could be fragments of text. They could be little subsets of a larger image. They could be audio clips, very short audio clips. Anything that is kind of an analog description of something, the world, of nature, if you like, can be processed in this way. Okay, so let me just show you what these 4 aspects are very quickly. So when you put in a sentence, an unfinished sentence in this example, and at the top, I'll just read it out: to date, comma, the cleverest thinker of all time was. Now, who are you going to say? What is the GPT going to say to finish that sentence? Now, before it can do that, it has to convert that text into its language, and its language is vectors. Now, vectors, these vertical columns of numbers, okay, represent the meaning, if you like, of those tokens. Now, by and large, you get one token per word, but some words that are either complex or they have subtle meanings, let's say more complex meanings than others, get broken up. So the word cleverest was broken up into three tokens in this example. Now, each of those tokens is, let's say, processed in some way, analyzed, and you get a list of numbers. They're usually presented as columns, and the mathematical kind of definition of that would be a vector, okay? And it literally could be used, if the dimensions are small, it could be represented by an arrow pointing in a certain direction with a certain length. It is a vector. It has length and direction. The problem is tokens and the vectors themselves might have 2,000 elements, 2,000 dimensions. Now, what on earth could go into those 2,000 elements of data? Well, if you like, the numbers represent various aspects of that word in context. So the word thinker could mean an academic. It could be someone who's thoughtful, is someone who's just got their eyes shut with their head looking to the sky. It could be all sorts of things. The definition of the term thinker is partly and largely defined by its context. So a lot of these numbers refer to context and its closeness to the meanings of other words, if that makes sense. It's hard to explain in more detail. As I say, I'm not an expert. This is third-hand knowledge. I'm actually, if you look at the YouTube link at the bottom, the URL at the bottom, some excellent videos there, which are the best I've seen for explaining this stuff. And it doesn't go into great detail, but it's kind of, it introduces you to some of the mathematics that is in there. So we have these four processes: embedding, attention, MLPs, unembedding. Embedding basically creates vectors for the, if you like, the question, the prompt. It's called embedding. I can't remember exactly why, but you get a vector out of that. And then you have this thing called attention, which is top right. And what this does is it looks at each token in the context of other tokens in the content it's got. So it will look at the other words in the unfinished sentence to say, in the context of this sentence, what meaning should I put on the word thinking? Okay, so it's obviously looking about thinkers, you know, this in this example. That is a complex process, okay, because it's dealing with the words that it knows about in the previous few, the tokens it's dealing with in the previous few words, but it's also looking at other data that you may have given it as context, you know. So that is actually quite an involved process. Now, beyond that, you have this thing called an MLP, which is a multi-layer perceptron. As a tiny bit of background, a perceptron was described first in the 1950s as a concept of how we emulate neurons in people's brains and use that to build, if you like, intelligent machines. That was 60-something years ago. So that's not new. And the mathematics followed from that in some ways. So it's only recently, or maybe the last 20 years perhaps, that we've had technology that can actually process neural networks. So the multi-layer perceptron, what it does is it kind of, simplistically, it kind of asks other questions about the tokens. Is this an English word? Is it a noun? Does it refer to a person? Is it an amount? Is it tone assertive? And so on. Lots of questions. And hundreds, maybe thousands of these questions may be involved. And so what happens is the attention process and the MLP process actually are iterated before it hands off to this unembedding idea at the end, which I'll come to in a minute. But an embedding is really just about a recognized dictionary, 50,000 words that the tool will recognize, and it prioritizes them in terms of probability. what is the next most likely word to get me further along in this sentence? What word do I need to add to this sentence to get it closer to making sense? Now, what you'll see, and this image is lifted from the same video that I've been talking about, and there's a whole series of videos. The transformer iterates over the attention and multi-layer perceptron processes again and again and again and again. It's not clear how many times this might be processed, but don't forget, these are huge arrays of data processed hundreds or maybe thousands of times to arrive at a destination. Now, what is the destination? It's the most probable next word in a response. And that's all it is. So all this processing is only going to deliver one word. That's it. Now, to me, you think, how can this possibly work? How can you generate a paragraph of text that has meaning, one word at a time, when you don't know what words are coming? You know, how can you think? So it's not thinking like you think. It's trying to build a sequence of words that make sense according to the probabilities that are built into its model. And that model was constructed from analyzing mountains of data, which you may or may not have ever seen before. Now, literally what the GPT is doing is it's generating words based on what it knows about the local context and any other content, any other data you've given it, okay? So at the end of the sentence, when it finally finishes and hands over this sentence, this completion, as it's called, the response looks both meaningful and well put, well constructed. I mean, it's probably presented in good grammar, okay, which is great. And it's very tempting to think that it's doing what you've asked it to do. Now, you might have asked it to derive some test cases. That is absolutely not what it's doing for you. It's looking for a sentence or a paragraph of text or an answer which makes sense, that is probably the best answer it could find in its knowledge base, which is the model. Now, if you don't put test design into the model, you don't get test design activities out. So you have to be very careful with this, to ask it to do clearly analytical thinking exercises. It doesn't think the way you want it to think. It doesn't think the way you would think if you took on that same task. Now, I want to suggest that testers need thinking tools. And by that, I mean the tools that we have at the moment. We have mechanical tools, test execution, record keeping, test management, that kind of thing. I want to suggest they do logistics. You know, they do some of the mechanics of delivery of the ideas that we have in our head. I want to suggest we really need thinking tools. And some of you may have seen before what I've called the new model for testing, which is a model of the states of our thought. It's a model of the 10 ways that testers think. Now, I'm not telling anybody that I know how people think. What I'm trying to suggest is there are patterns of thought that we go through again and again and again as testers. And one is asking questions of our sources of knowledge, who might be people, might be documents, might be the old system, it might be the new system when it's available. And quite often we have to challenge and say, well, look, if you're saying this, my suggestion is, this is how the system works. Is that correct? We actually ask questions and we challenge our sources, if they're human, for sure. If we're exploring a piece of software, we try things out to see if is my understanding of how the software works correct. Now, there are 10 of these arrows. The blue arrows are the 10 thinking states. But it's not a process to follow. It's just an attempt to describe the various thought processes that we have in creating tests that have meaning, okay? Now, test execution tools, although they dominate most people's understanding of what test automation is about, they only provide some support to what I've called the applying thought process, which is applying a test. Now, that application might be with a tool, it might be a human doing it, But at any rate, there's not an awful lot of thought going into that once you've created and constructed a script or written some code, or you've prepared an idea and moved that towards a test case that you want to execute in an exploratory session, for example. So the tools are not helping us very much. In none of these areas are we getting a lot of support. Now, the way I look at these things is, and this is one way, this is one slice on how we look at tools. I look at it in two dimensions. Can these tools record, capture knowledge that we discover as humans? That would be one dimension. Can we do this? And the second dimension is, can they ask the questions themselves? Can they do what testers do, which is to read documents, to interview people, to explore software, to look at data? Can the tools do that? These are the two dimensions. And if you like, every consultant has to have a 4-quadrant model. Well, the 4 quadrants here are derived from the ability to capture knowledge on the vertical and the ability to investigate, to ask questions, if you like, on the horizontal. Now, you can see there's not much on this diagram. It's not a very useful diagram. We have tools to capture knowledge, and there's 100 things we could put there. But we don't have tools that will ask questions on our behalf, which will do some of the investigation, which will do the exploration that we need. And exploration, to me, is universal. We use it in exploratory testing, but we do exploration on different content, on different sources of knowledge, in structured, waterfall, documented testing as well. Exploration is what every tester does. Now, the ability to investigate, you could say, well, okay, what are the ends of the scale? What's the lowest capability? Well, the tester does everything. The tester does all the thinking and has complete control. Well, what would be the other extreme if the tools did it? The tool formulates its own questions. It takes the answers. It discovers information. It analyzes what it gets. It makes models. It judges relevance, completeness, and accuracy of information. Does all that. Now, that's a big ask. Maybe machine learning AI can help us there. So I want to say that we don't need smarter test execution tools or even smarter test management tools. There is some value in using large language models in this respect. I'm only talking about large language models just for this topic. They're not going to help us in the ways that we really need, which is capturing models, test design, test data management, generating data for good test cases, interpretation of results, all that kind of stuff. So I've got a quick section which I need to get through. I think I'm on 40 minutes now. So to look at how machine learning AI could help us, I think, to generalize, there are 2 testing styles. There's the structured waterfall stage testing we all know and love or hate. And then we have exploratory testing. Now, I don't want to get into the battle of which one is better than the other. That's not the point I want to make. What I want to say is there are benefits to structure and there are benefits to agile, if you like, with a small a, exploratory testing. These are all well understood. We know this. And there are obviously very well understood disadvantage to these things. Structured testing tends not to be as flexible. It's not responsive. It becomes obsolescent because of documentation challenges. Exploratory testing sometimes isn't repeatable. You can't hand it over to other people without giving an awful lot of background and context. You don't get so much documentation. It's not necessarily automatable in as easy a way because you don't have any script to work from. You get the idea. The point I want to make is that we need the best of both in order to take advantage of AI. This is the thesis I have. We need the best of structured and exploratory testing to gain the benefits of machine learning and AI. Now, the biggest area I think that we need help with is this idea, this concept of exploration, building models. So we need tools that will allow us to capture models and tester activity in real time. Okay, we need, as we explore software, as we read documents, as everything we do, we need a tools interface to pick up the knowledge that we gather as we survey what we're looking at. And I like to use this surveying metaphor as a way of explaining what I'm trying to get over to. System surveying, You could call it exploration of the system, exploration of documentation, a conversation in front of a whiteboard, diagrams. It's all surveying, okay? We're surveying sources of knowledge. Now, in a physical sense, it's a bit like surveying a town. You could say that the map of a town is the model of the town. It's a logical model, not a physical model. In the same way, we can create models of software, of user behavior, of message paths, of all sorts of aspects of our systems. As we survey, we build up a model bit by bit. It's an incremental, iterative, emergent activity. It takes time and effort to create these models. Now, while a tester is exploring a system, I want to capture information that can be used to build that model. I want to be able to capture paths through the system and link them all up so we can see a network of paths through our systems. And in principle, this is something we could use for coverage, but literally we should be able to, with some caveats, create an automated test script from this material as well. The information required for scripting is in the model. Now, I know there are complications there, but if we have the data, I think we can generate these scripts. Now, one thing I want to emphasize is I want it all captured. Now, what do I mean by all? For every exploration activity, I want to capture mouse clicks and button clicks and data entered and stuff like that. I want screenshots. I want to see the content of fields on screens and the behavior as I experience it as a human. I want the tool to capture it. So I'm constantly working through a tool. But I also want the messages between my device and the web server or backend services or databases, whatever. I want all those messages. I want to know which data changes and when, and what activity from the user's point of view trigger changes in data. I want to know all the physical attributes of my client as I process transactions. I want to know how much CPU, what the data, the I/O situation is, memory, all that good stuff. I want it all the time for all time. Now, that's a big ask, but if I have that, some remarkable things become possible. I think we can work towards a scalable, automatable process. Humans do the exploration, but the tools are capturing everything as they explore. Having built a model, we can review and refine the model as humans, but that model can then be used to generate tests and achieve coverage and to track progress through our testing. So the paradigm I want to introduce very quickly is this concept of an interactive test environment, a bit like an interactive development environment, which is what every developer uses nowadays. And there are kind of 5 modes, 5 activities. The survey mode, I want to capture models while I'm exploring systems or I'm exploring requirements. I mean, everything. I want an edit mode so I can change the content that they've captured if I've misinterpreted or made a misstep. I obviously want to change it. I want an interactive test mode, a bit like a debugger. I want to run a test manually, have that captured, all the results captured, and that gets filed away and it's available to the tool. I might want to run tests unattended. Now that's great. We've got that already, but there's no intelligence behind that. We're just running a script or a series of scripts or 1,000 scripts. That's fantastic. But I want the tools to be monitoring everything as they run these things to see if there are patterns or anomalies in the behavior of messages, servers, or the resources on any hardware. I also want an autonomous mode. If I go to a meeting, I want to come back to my desk and the tool to tell me, while you're at your meeting, Paul, I had a look through the regression tests that we de-scoped 6 months ago, and I thought I'd try to run them again. And some of them run, but they caused failures. Now, that would be really interesting, wouldn't it? To have a tool that actually works behind your back, but with your authority, approval. Okay, I want all that. That's what we need as testers. So testing and automation becomes a modeling problem, not a scripting programming. The scripting programming happens behind the scenes. There are fantastic tools which are no code or low code. That's great, but we still have to capture them manually. Well, I want all that taken away as a task in my sorry, I need to drink. I want all that taken away. Obvious. Okay, quick. I'm running late, I think, so I really apologize. So can we trust automation to test everything? I don't care. I think that's a stupid question. That's not the question we should be asking. What I think we should be thinking of is we need tools that are ever present, supporting surveying and testing. The tester decides when to explore the territory, to run tests, to let the robot, the tools do their own thing. We should be in charge, but some of the testing tasks need to be taken away because only the tools can do it sensibly, because only the tools can monitor the messaging and the message paths and the CPU usage and database changes. Only tools can do that. And yet, if we have tools that can do that and spot anomalies and tell us there's something not quite right here, I think that would be incredibly powerful. So I think it's a great opportunity for testers. The opportunity for testers is to have a bigger impact on requirements at the front end. Maybe AI can help with that. To capture surveys and the system model, absolutely, I think we need tools that can record content and analyze content and spot anomalies. Absolutely, we need that. The tools can also act like a pathfinder or a navigator. We can ask it questions on what if we change the functionality of this screen to do something different. I would expect the tools to give us an answer to that potentially is very informative. Tools offer suggestions and make choices, but it's under the control of testers. Now, ultimately, this might mean fewer testers, but I think it's fewer smarter testers with superb tools. Thank you. I'm sorry, my voice is...
Your voice is fine. Thank you.
Thank you very much for the presentation. It was really incredible. And I really enjoyed the example with the brochure. It again just pops up in my mind that is it possible to install it on my GUI on my website, because it will like solve a lot of problems, you know, with asking questions what we do.
My first impression was I was always thinking about with brochure as consisting of only photos and images. So my first thought was, is it multimodal in private GPT already? But no, it looks like there is some text there as well. So it's fine.
I think what I'm trying to do is to figure out how to analyze content on webs. This is what I'm trying to do with the tools at the moment. I'm trying to look at websites for test service providers and tool providers to understand the language they are using to describe what they do, and kind of map that to the definitions that we've got of agile testing, performance testing, functional testing, all that other good stuff, and to see if there are patterns of failure to describe what they do, as well as patterns of success. Because, and it's just it's probably a piece of marketing analysis, a study of the market, if you like. But even so, it's just an exercise. You know, if it has value, I'll talk to people and say, look, I've got something of value. But if it doesn't have value, I will still learn something. So it's a hobby almost, but I hope to get something out of it.
Yeah, that was my actually next question. So when you started the presentation, and by the way, for the YouTube audience, please submit your questions if you have any via YouTube chat, and we are going to check that just in a minute as we are slowly moving to a QA session. So my question was around, you mentioned in the beginning of your presentation that you are actually not sure what is the future of this own GPT project. What do you think now? So while you are in the process and you see all these capabilities around and you're developing this tool and working on it in from scratch right now, what do you think would be the future of it and how we can use it?
I think I think two things to say. One is GPT is not just about large language models. GPT is about numerical analysis, data, what you would understand as data. Now that data can take any format. So the question is, well, I want to understand how GPT works with respect to language and language models and how we can get value out of it that way. But by so doing, I also want to understand how it will do that with numeric data. Because ultimately, a lot of what testers deal with is text, sure, requirements, text in some format. But a lot of what we do once we start testing is numeric data, whether it's response times or messages sent and received, probabilities of answers being correct or not, whatever. There's an awful lot of numeric data that I think has value. So I'm doing it as a learning exercise for myself, but also I'm trying to understand better what it can do for us, large language models and GPT can do for us, and what it's not really the right tool. I think that's kind of my goal here. I'm sorry.
Question here probably from somebody in technology. What do you think about necessity to split RAG from LLM? So in your current experiment, you have both of them in the same product. Have you considered having separate models responsible for retrieval and then submitted to a separate LLM?
There are multiple. There are 1,000 language models available now, and there's kind of a hit parade of which ones are the most accurate in terms of passing standard tests. They tend to be like American SATs, is it? I can't remember now. But passing kind of artificial tests. The problem is that they're artificial tests, and probably those tests have been fed in as data already to these models because everybody knows that's how they're going to be scored. So it's obvious they've done that. So can you trust them? I don't know. I'd rather not look at the hit parade, but actually get a model in place and just use it and try and do something useful with it. The problem I think we have with this is it's like interviewing people in that they're not human. I'm not saying that, but every person gives answers from a different perspective. In the same way, the models quite often have come from a different perspective, and that's recognizable. So a model that's been trained on, let's say, social media data is going to give you a very different answer from one that's been trained on scientific papers from universities and academics. So how do you rate a model? Well, you've got to find one that's using as close a fit to the data you want to use as you can. Now, if you're looking for support in testing, well, who's out there creating a model trained on reviews of requirements, software exploration, test execution, statistics? Who's got that? That's what I want. And I'm not sure there is one, because that would be incredibly valuable and commercial interests would want to make money out of it. And I don't know if anyone's actually doing it. That's the problem. But here's my challenge. Please talk about what you're doing and tell us how you're getting value out of large language models by using data from real projects, from real software, from real testers, and so on and so forth. I think that's what we need. I don't know whether we'll get it, because it's kind of knowledge is valuable. That knowledge is valuable.
Do you think defect description databases available for open source projects can be a source of this information, or open source projects are different from the rest of the industry? So what can be extracted from the pull requests or issues is not necessarily be applicable to other contexts.
Well, the thing is, the open source projects tend to tell us what they're doing. You know, they tend to be open. They're open and they're not secretive, because everyone can see the source code. The data is there in the models, and so on and so forth. And the commercial companies don't tell us very much, and so we don't know. We don't know what we don't know. If that makes sense. So it's a bit of a mystery. But I've been watching recently. The reason I'm probably coming across as more skeptical than other people, and partly that's because, you know, I've experimented with it to try and ask ChatGPT to design tests and so on and so forth, and had some experiences there. And it's a bit hit and miss. It's not reliable. It could be of some help. I'd say that's the way I'd put it. But interestingly, there are now more commentators saying that GPT is now hitting a problem because the language models with 500 billion, is it objects or tokens? I can't remember what the word is now. They're running out of data. There's not enough data to feed the models. So the models aren't going to get very much better over time now. And now, so what can happen then is you could use the models to generate data, but that data is tainted. It's damaged. It's got noise in it, in a way. And it's a bit like photocopying a photocopy of a photocopy of a photocopy. Eventually, you lose the image, and you lose the information on an image. It's a bit like that. So there will come a point in the next, I don't know, year or 2 years when models will get no better. And they're already at a certain level. Is it, I don't know, 87% of scores on some of these tests? I don't think they're going to get much better than that. And we've got to live with that. So they are imperfect up front. They're never going to be perfect because we don't have the data. The academics need to figure that one out. So I am a little more skeptical than I was a year ago, or maybe 2 years ago. I thought, oh, this is really exciting. And I think it's still exciting, but I don't have such high expectations anymore.
Thanks, Paul. I would like to change a bit the angle from the data to the relationship between software tester and AI itself. So when you've been already explaining and concluded already that the relationship between software tester and QA and AI actually should be as some kind of AI should be some kind of thinking tool or trustable advisor of what is happening. And so we need to rely all the routine tasks to it, but we should decide. Yes, and you just mentioned that in autonomous mode, for example, you're just leaving your AI helper and going to the meeting and going back. So
Yeah.
what happens, my question, what happens when nothing happens? So your AI helper doesn't find anything. So what are you going to do with that? And another question is if that's interesting, something interesting flags up, so you see it from your helper, but what do you do with the rest of the data? So the data stores, and you're saying, I want it all. I want to see all of this data. What are you going to do with that? So sorry I have a few questions.
But about when big data came along, I thought, what can testers make of big data? And I came to the conclusion that we capture lots of information that testers would find really useful, but we don't have tools to log this information, to analyze it, to come to conclusion, to spot anomalies, etc., etc. So this is not a new kind of idea. And then the question is, well, which data do you want? Which is the most valuable? And I think, well, you don't know what's most valuable because you don't know what's most valuable until you analyze it. And if the tools find nothing, okay, you move on to the next kind of data. So I think our attitude should be, we want it all if we can get it. I know we can't, so we have to, as usual, take what the tools providers give us. And if a tool finds nothing, well, that's fine. They move on to another area. and that's that's obvious. If they find something, the something might be just like a tester finding with a is that a failure or is that not is that a requirement? Should the software do this? That question can't be answered by the tools. It can only be answered by the people who write requirements, or the users, or sponsors, or whoever, stakeholders, call them what you like. So it's a trigger for a conversation. So again, a user story is a trigger for a conversation, isn't it? So I think that would fit quite nicely. So if tools work in the background and see anomalies in the movement of messages around servers, the usage of resources on hardware, and obviously expected results not being met, and the expected result might be I ran a test yesterday and I run it again today, I get a different result. What do we make of that? Now the tool might give you the answer and saying it must be because the environment has changed, because the data is the same, the software is the same, someone's changed the operating system environment, or they've installed some layered product which affects the behavior of lots of other libraries. Who knows? I think the tools should be there to tell us, here's a problem, but by the way, here's where you might go and explore and diagnose where the problem is. So I think the opportunities are there to use tools in a very exciting way, but it's becoming more and more technical, what testers do. It's not just about understanding a requirement and running a simple test to say pass or fail. I think we become very powerful diagnosticians. I'm just making this up at the moment. I'm not, I've not thought this through, but my guess is our thought processes are going to be, there's so much data out there. The world is such a complex place that we need tools to give us, accelerate our understanding of what this data all means. A bit like a general practitioner, a doctor. You've no idea, the person who walks through the door, you've no idea what their problem is. And so how do you get to a diagnosis, and when do you hand off to an expert? Maybe we're becoming a bit more like that. I don't know, but it changes rules. It changes our behavior. It could change our behavior dramatically, and that we know how to test, but a lot of the legwork, the logistics, I would say, is done by tools. So we're not as close to the action in that way. We might lose something by that. The human observer is obviously the most valuable part of exploratory testing, and automated testing. There is no human observer. So there's no one there to, oh, look at this, look at that. Tools don't do that unless you program them to.
Yeah, yes, that's right. But how about the level of trust? How can you measure that, the level of trust to that AI? So is like the sentence, the responsible AI, is it real or is it just a myth?
It's obvious. It's an obvious question. Can we trust this stuff?
Yeah.
Okay, so firstly, now that's not to say it's not an incredibly important question. Now, what's the answer? Now, if you ask a tester, when will you trust this AI? And they might say, well, when I've seen all the processing of data from end to end. Okay, well, what we could do for you as developers, I'll wear a developer's hat. What we'll do is we'll print out all the intermediate results of all the calculations right up to the end, which says Einstein. That's the answer. Now, there might well have been 10,000 processors working on that question. And so if you capture all the intermediate, the working out that goes on, you might have 1 billion pages of text. Now you can give that to a tester and say, right, the actual result is one word, Einstein. Here is all the intermediate calculations that have been done, and it fills a warehouse with paper. How are you going to judge that? How are you going to analyze this? All you can do is to say Einstein sounds like a reasonable answer. And if you like, I don't know how to put this. I haven't really thought this through the way perhaps I should, but I'm tempted to say is that we've got what we asked for. We didn't expect perfection, but we expect something that sounds reasonable. It sounds okay. Well, that's what we've got. We've got an answer. Einstein, the greatest thinker of the past 100 years, whatever, that sounds reasonable. Any human being who had some common sense could give that answer. So how can we say that's wrong? But it's not perfect. There perhaps were better, more marvelous, wonderful thinkers than Einstein, Nobel Prize winners, and so on. Who knows? But the thing is, we've got the answer we asked for, which is almost like an opinion. And an opinion is never wrong. It's an opinion.
Yeah, yeah,
Does that make
right.
sense?
Yes.
So I'm not sure we're asking the right question, you know.
Yeah. Yeah,
Yeah.
so it was yes. So we could just go to a bit more complex area. I'll take one more, Joseph. Or do you want to ask a question?
Yeah, maybe follow up for this one. So
Yeah.
essentially, it is the question of when to stop the testing. So it is particular case. So when we can be sure that we are no longer able to extract additional information in a cost-efficient way from the system. So it is,
okay.
if software tester believes that they are able to find more problems with the responses of the system, they can say that this is what we are able to find here. These are the defects. But if after some point we are no longer able to identify problems in a cost-efficient way, we can say, yes, this is the point where we can stop testing or something like that.
Yeah. I mean, it's there are two ultimate questions. One is how much testing is enough, and the other one is when do we stop? And it's kind of the same question in some ways. I think so the question, when do we stop? You could say somebody somewhere is paying the bill, and when they think they're not getting a value for money, that's when it stops. Now, what does that actually mean? What is the value? Well, the value of testing is it provides information to help people make decisions. Now, the people who are making those decisions tend to be developers make decisions. They are a stakeholder for us. They make decisions on whether it's a bug or not a bug, whether to diagnose it as a bug or do something differently, together with other people. The guy or the person who makes a decision to go live, they need information from testing to make that decision. So the question is, who judges the value of the testing? Well, it's not the tester, it's the stakeholder. And the stakeholder has to say, am I prepared to pay more for more information that will be helpful to make my decision? So I want to make decisions that I'm 100% confident is correct. So I want as much data as you can collect. Now, the problem with that is that data could be mountains and mountains of scripts and incident reports and retests and all that kind of stuff. So what format does that information take so that the stakeholder can digest it and use it usefully? And when does it become less useful? Well, the only person who can answer that question is the stakeholder. And the stakeholder also has the other piece of information, which is how much does it cost and how much have I got to spend? So it's all in the head and hands of the stakeholders. So it's not a question for the testers.
Yeah, and by the way,
it's not a non-answer. It's not my problem. I'll do my best to get to a point where we're doing the right balance of testing, but ultimately the stakeholders have to give us that direction, is what I would say. That's not changed by AI, I don't think.
And by the way, can stakeholder be an AI? Can the stakeholder be an AI? Artificial.
Sorry. Can the stakeholder be an AI?
It is a question from YouTube channel.
Yes. I'm just following that.
Oh, that's interesting. I've never had that one. I don't know. Obviously, I don't know. But I don't. Someone's going to tell me I'm completely wrong, but I don't see why not. if we can get the information out of stakeholders' heads into a model so that it can predict what stakeholders will do when asked the question, should we release, should we not release, or is this a bug, yes or no? Should we fix it, yes or no? Should we pay for more testing or stop testing now? If you can capture that information, I'm tempted to say you might get a robotic stakeholder. I don't know what it says though.
In particular, James Bach believes that AI is both unreliable and unresponsible. And in contrast to that, humans are also unreliable, but at least we learned how to make them responsible, because it is possible to do something with a human. And AI has no fear, no pity, no, they are not scared of anything. So that's why they're not able to be responsible.
Yeah. I think I'm tempted to say it's the people who own the output of AI that have to do the trusting, because they've, so do we trust AI? Yes or no? I think it's a similar question to do we outsource our development, testing, other piece of work to people I don't know, to strangers, let's say, whether they're in the same country or in the one of the obvious countries. People had to come to terms with the fact that they lost some control, that they weren't dealing with employees, they were dealing with a supplier, and that's a very different relationship, that they don't have control over who those people are. That is, they didn't recruit them individually. They are provided by the supplier. They're chosen, trained, motivated, paid by the provider, by the supplier. So a learning had to happen. Now that learning became humans in the customer and humans in the supplier figuring out how to communicate better, how to get things done, how to make progress. I'm not sure humans can talk to AI in that way and negotiate. I'm not sure that's how it works. So I think it's a real problem. It's a real problem of trust. And the challenge, I suppose the challenge ultimately is it's not the model. It's the data the model was trained on. And to date, that is a mystery, isn't it? I mean, I don't know anything. If that could be audited and it was publicly available, here's the data sets that trained this model, and there were kind of guarantees of its accuracy or reliability or the source or and so on. Maybe we would trust it more, but for now, I'm not sure we can trust it in the same way that we would like. So it's a challenge. It's a definite challenge for us. Do we trust what the AI is doing? A friend of mine worked for a tool vendor, and they put AI into one of their products, and it was to do with monitoring customer experience kind of activity, monitoring logs, response times, And the model was coming up with anomalies and answers to questions on satisfaction, customer satisfaction. And it did it really quick. And as far as the vendor were concerned, that's the answer. It gives you the answer faster. But the customers they were trying to sell it to just didn't trust it because there was no human interaction. It just came straight from the data. So it's a human problem that we've got here. It's not a technical problem, I don't think. Humans have to either understand the data or the tools much better to understand and trust, or they take it on someone else's word. Or you have to do it yourself. You have to have a play with it yourself and ask it questions you know the answers to and see whether it gets those answers right. The difficulty is could be a very time-consuming thing to do.
Yes, so a practical example would be that if we have AI tool capable of finding defects, and then here we are bringing these defects as the information uncovered, and then the end user stakeholders, they can say, okay, we can see the output, so we can see defect, but we do not know what was tested, and we do not know what is the test coverage. And I'm personally, and other people in Exactpro, we are big fans of your test axioms project. And one of them is, of course, that there always should be a coverage method to calculate coverage.
Yep.
And
Well,
here can be the question, okay, so you have VCI, and it identified a number of bugs for us. And then it was doing something in the background, going through the big data. So how do we evaluate the coverage metrics for this particular case? And how we can say what is covered, what is not covered? So there are some petabytes of data collected by surveyor. So, but what is our coverage percentage or something like that?
Well, I think so. A lot of the functionality of the models when they're running on NVIDIA GPUs, and NVIDIA completely dominate this space at the moment, which is another concern I have to add for some people. That functionality mostly is mathematical. It has mathematical precision, so it works. It probably is as near to perfect as it could be. Now, the process of putting these functions together and the mass processing of huge matrices and stuff like that there's a notion of probability in there. So I'm sure you know this. Now, if you ask the same question, if I asked, and I think I did it this morning when I was putting together that little video of me using one of your documents to find out what you do. If I ask the question, what services do Exactpro provide? I'll get some text. If I ask the same question again, I'll get a different answer, because it clearly believes I didn't give the correct answer. Maybe there's a variation. I don't know how this works, but because there's a probabilistic element to it, it's not deterministic. That is, there's no right answer. So how are you going to test that other than by saying, well, I've read the text and I've read what I wrote in the PDF. It's a good summary. It's okay, but it's obviously emphasized this more than that. So I think the bugs in these things would be bugs of emphasis, not completely incorrect. I mean, there are bugs like, the hallucination and all that kind of, it's inventing stuff. Yeah. Get all that. That's a problem, and we need to resolve that. But it could be that the difference between two responses to the same question it obviously thinks performance testing is more important than functional testing for some reason. Now, for somebody, that's the right answer. But for other people, that would be the wrong answer. Or maybe the person who wrote the document, it's the wrong answer. They've got their message wrong. So it might be the person who wrote the document in the first place, who made the mistake, who needs to change the way they write that document. I'm not saying your document is not good. I'm just saying this is how it works. It's about probabilities, and we want certainty, and we're not going to get certainty out of GPTs, I don't think, and large language models. I would trust the numerical analyses more, but text, the embedding idea of creating a vector for two different terms, and if the two vectors are close, they have similar meanings, and if they are a long way apart, they have nothing to do with each other. That is subjective, and I think there's a human in the loop there. That means that, which definition of the word rose? So rose could be a flower, could be I'm getting out of bed. I don't know why I said road. I think it actually has lots and lots of different meanings. I just can't think of the others now. Things emerging, I don't know. But a human has given those definitions. And the problem is we have to live with multiple definitions of the same word already. And we figure it out. And I don't think software figures these things out the same way we do. So I don't know how we test it.
Thank you. By the way, about multiple definitions, can you share with our audience the project, the glossary project that you're running? And I have not seen their definition of AI yet and definition of bug. I understand that you've been on a break for some time from that project, but are you planning to give the description of both of these terms in the future?
Well, the glossary, what I call the glossary project, was an idea. Whoever you talk to in the testing world, if you say, what's your definition of integration, you'll get a different answer. I mean, similar but different. They might say integration to me is component to component, put it into our CI system. It's like unit testing with a little bit of integration. That's integration to me. If you go to an SAP consultant, they would say integration is large scale, traversing business processes from the beginning right through to the end. And there might be 50 stages in the use and reuse and creation and deletion of data across these 50 stages. Integration means something very different to different practitioners in our business. So we have to live with that, so each term, some terms have multiple definitions and they're all correct. You have to understand the context before you choose your definition. Now that scares some people because they think I want one definition and that's the end of it. That's, so what they then do is they create a variation. So integration in the large is a different thing from integration in the small. So component integration is different from large scale integration or system integration. So what happens then is we invent all these new terms which cater for these variations. And so then we have things that are almost synonyms, but not synonyms really. We get ourselves in a mess. We are in a bit of a mess, I think. But I think that's what comes of being a young industry. So what I've been trying to do is to say, here is a term, here are 2, 3, 4 different definitions. Choose the one that suits you. And none are right, none are wrong, but if it's useful to you, and this is the term, the definition, use that. Now, what is interesting to me in the AI, in the GPT, the large language world, is at the end of the day, the word that it appends to its response, to its completion, is lifted from a dictionary that it has. So the LLMs have a dictionary. Now, I don't know if they have definitions or it's just a list of approved words. I'm not entirely sure about that. But it's interesting to me that we need to have not just single word definitions, but also 2 and 3 and 4 word terms. We need definitions for those as well. So large scale integration testing is a 4-word term. It's not 1 word. So it's quite a challenge. So anyway, I'm just trying to put it out there as something that is useful. And you obviously know I'm occasionally do videos and try and explain integration or quality or component testing. I've done about 20 or so. I think there are 500 terms.
Yes,
so
yes.
It might take me some years.
And it seems for us it's very important project. Yes, and
Yeah.
please continue doing
that. I need to build a team of people who, I mean, to me, the way to make this work is to build a team of people who can, if you like, create those videos and capture that narrative and give that as it's a 10-minute explanation. It's not a definition. It's an explanation of what it can mean in different contexts. I think that's more useful to us, isn't it? If I do 1 video a week, it's 10 years. So I'm not sure I'm going to be able to do that. But maybe someone else will pick it up. But I will come back to it. I've just been really busy the last couple of months.
Sure.
I've been busy.
Sure. So. Thank you for doing that. Anyway, I think we need to wrap up because I'm conscious about the time. Joseph, do you have any more questions?
I do.
Yes.
So I know that you have a lot of work on your hands already on the new model of testing. So I have 2 questions. The first one is so one of the basic ideas is that we need to separate logistics from the test logistics from the thinking. But there is a school of thought that intelligence is related to the logistics. So depending on the tools or sensors that we have, we will have different thinking. So essentially, if we would have a different number of fingers on our hands, we would have a different numerical system. So so one thing is when we're talking about human testers, but now we are also trying to involve software into building models. So how they can be affected by the fact that we are trying to abstract them from the logistics of testing?
It's a good question. The way I think about it is there's kind of a principle at stake. And if you take models, all testing is based on models, and most people, I think, would agree with that. It might be written down as a model. It might be a model that's given to you by some designer or business analyst, whatever. It might be something that you sketch on a whiteboard. So you invent your own model. Maybe that's, or you just do it in your head. I don't care what choice you make. That's a choice for you. That's a logistical choice rather than a principle choice. It's not a different principle. So to me, the thinking is about what's the principle at stake? I need something that helps me communicate the quantity of testing so I can talk to a stakeholder and saying, my plan is to use this kind of model to show you what I'm doing, to evaluate the quantity of testing, and by covering it, to give you some confidence. Now, what does that model look like? Don't know. I haven't created it yet. So I'm working at that level, not the let's actually start writing out the model. And you could say, okay, what about incident reporting? Yeah, we all have to do incident reporting at some level, whether it's a sketch on a whiteboard or we have a tool or whatever, or Excel or whatever it is. I don't care what those tools are, but the principle is we record an event that has significance, which could affect the success of the project. That's kind of its definition, I actually forget what I call the axiom there. I think it's just called the event axiom, isn't it? Events happen, and they can be good, they can be bad. Just pay attention to them, and what those events are and how you record them, that's logistics. I don't care. You decide that with your team. Some teams love to document things. Some people like tools. Some people will use a whiteboard. Some people just use word of mouth. I don't care. The principle is the same. So it's kind of operating at that principle level. But those principles are whether you're the tester in an agile team or you're running a team of 500 testers on a massive banking project. The principle is the same. You're going to keep an eye on events. That's how I would answer it. I think one criteria for deciding whether it's logistical or not is there a choice? Documentation, is that a principle? No, you have a choice. You can write stuff down or not write stuff down. You can use tools, you can not use tools. You can put things in great detail or just high level. These are all choices. If it's a choice, it's not a principle. It's probably how I would argue that one.
Thank you. And probably the last one from me.
Last one.
Yes.
I thought we were going to talk for 10 minutes.
No, sorry.
It's fine. No, it's absolutely
As
fine.
software testers, we constantly ask questions. So my question is the following, and especially we have quite a lot of young people, young folks who are building their career in testing. And one of the questions that they might have is that now everything is digits, embedding, machine learning, and it means that LLMs or other machine learning algorithms, they do not really care on specifics of the text. So they just extract information from the data. And if everything is extracting information from the data, how important is domain knowledge, specific domain knowledge for a software tester, or everything will be everywhere, just machine learning. So we use our brains as humans, and we can apply our brains to different areas, different contexts. So maybe the software is also will be able to work in very different contexts. So is it still important to study particular domain to become a subject matter expertise for a software tester, or it is better just concentrate on exploratory data analysis?
I don't know if one's better than the other, but if you come into a project, well, I mean, you provide testing services, and when you get interviewed, because I did that job as well. I've been selling, consulting, testing services, for many, many years. I don't do much of it now, but whatever. But it's not changed, I don't think. So the question will be, if you go into a bank, they're going to say, well, have you tested a banking system before? Now, I could say, because I've tested lots of stuff over nearly 40 years, right? I've tested lots of stuff. I don't care if it's a banking system. I can test anything. I need to know, personally, I need to know what questions to ask of the right people to get the information, to find the domain experts who will give me the information I need to do my job. So I could say to the client, I don't need to be a domain expert. And the client will say, if you're not a banker, you're out, you're gone. So it's important to stakeholders to work with people who make the effort to learn some of the business domain, the domain expertise, who take the trouble, who put effort in to understand the business domain. I think that's a human thing. It's always a good thing to know more about the business than the developers say, because then you can outwit the developers very easily, because they don't understand. They don't often get into conversations about the business in the same way that testers do. Now, could AI replace that? I think that's a question for the domain experts, not the testers. Now, I think most domain experts would say absolutely not, because that's my job. If the tools know my domain perfectly, what do I do? What's my job? But having said that, I've wrote it down some. So there's a thing called Catala, Catala, Catala. And if I've written it down on my, I've got a whiteboard just there. To me, it looks like a programming language for the law. And what it does, it's a domain-specific language that describes legal rules, I guess, the law. And I thought that was really interesting. I wonder, could we have a language for testing in the same way? And there are some, I can't remember what it's called now. There's some formal languages that describe tests on embedded systems and high integrity, some stuff like that. But does that mean testers are out of the job? Don't know. A lawyer's out of the job. Some people will apply AI to the law to give advice. Now, you might say, okay, if I pay a lawyer, it's how much is a lawyer? 500 euros an hour. If I go on the internet and talk to my AI lawyer, it's $10 a question. Well, I might try that. But, this is what humanity is going to go down this journey. We've got to come to terms with what we trust people for compared with what we trust technology for. Self-driven cars, some people will never trust a car that doesn't have a steering wheel. Why? You don't need a steering wheel if it's self-driven. So would you trust? No, I wouldn't. I like driving, so I'm going to have a car with a wheel. Thank you very much. So it's a human problem, isn't it? And we've got to come to terms with it, I think. It's been very wide-ranging, this conversation, hasn't it?
Thank you, Paul. Joseph, did Paul address your question?
Don't apologize. I know I've enjoyed it every minute. It's been great. Thank you so much.
Thank
It's
you.
really interesting to have these conversations, I think.
Thank you very much. I think that we ran out of time and questions as well. We have
Oh, great.
a few we have covered a few questions in the chat. Some of them were not covered, but we could address them in a written way. I know these people. We will share with them the response later. I would like to thank you, Paul, for this fascinating conversation. I enjoyed it a lot. It was a real pleasure. Thank you very
Me
much.
too. Me too.
My last question to you, can you give us some tips how to find you, where to find you, which
Well,
website
I'm still sharing my screen, aren't I?
Yeah.
So you can see. Oh, no, I didn't want to do that. I lost it. Here's my email. I'm on Twitter. I don't use Twitter very much. My LinkedIn. Look me up on LinkedIn. It's
Okay.
probably the best way.
Yes,
I'm
right.
more active on that. I've got a blog, but I don't write blogs very much. But that's my email. That's the best way, probably. Or LinkedIn is the other way.
Okay, that sounds great. Thank you very much. Can I please take the sharing screen capabilities just to give our audience 2 slides more before we wrap up?
Okay.
Thank you very much. Wait a second, and I'll share my screen as well. So I just wanted to tell our audience that we're going to have so we're happy to announce the next webinar taking place on 18th of June, where we are going to talk with Oliver Denou, president of the IS2QB, and we'll discuss AI basis and some updates regarding IS2QB CTA course exam and more. And what else? If you are interested in leveling up your career and discover ways of leveraging the power of AI tools, do check out our website to learn more about the award-winning IS2QB accredited AI testing course. So registration is already on. So and do register for the next 6-week course enrollment. So the course starts on 10th of June. Please check the information on the website with us and stay tuned. Don't forget to subscribe to our channel. Stay tuned with our LinkedIn, YouTube, and other channels to learn more about webinars and events and upcoming and Exactpro news overall. And I want to say thank you again to everyone who was on our call today. Thank you, Paul, for this insightful conversation. And I hope and wish your project to grow and to find new capabilities around it and to find the business value with that. So, and see you all next time in June. Thank you very much.
Bye.
Bye.